with static electricity, it's often easier to see this in sort of a, using this as an idea. So here are some sort of examples, and we're going to work through. So we've got a photograph of an investigation of static electricity. We've got a teacher on a balloon with a cloth. So the balloon gains a positive charge. So we know that this is therefore positive. Explain in terms of moving charges how the balloon becomes positively charged. So I would say that we've got is a friction causes the balloon to lose negatively charged electrons. That's sort of my. So once we've rubbed it, we've got a positive charge there. Explain why the teacher's hair rises. Well, we've got a positive object. We will have in the teacher's hair, we'll have negative charges in the electrons that are in the atoms in the hair. They want to get over here. So the positive balloon attracts negative charges. There we go. Suggest why the charge remains on the balloon even when it's being held. So there is an earth connection. So you could think, oh look, we've got negative electrons are down in the earth. They could come up and go around the outside and onto that. The thing is, this is an insulator, which means that charges can't move very easily through insulators. So it's an insulator. So it takes time for this to occur. Suggest why the experiment does not work so well when the air is humid, damp. So when it's humid and damp, we know we have water. We'll have water molecules around this balloon. Now water is a conductor. Okay, so what that can mean is that negative charges from the water are able to flow onto the balloon to neutralize it. So, I mean, it's 1 mark, so it's only asking us to give a very simplistic answer here. But we would get, water is a conductor. So, electrons can flow onto the balloon to neutralize it. Okay, so that's the thing. I mean, this always happens because it's humid. There's loads of it, and that will dampen it down. So there we go. That's one example. Look at this one. Oh, look. Someone's rubbing a cloth with a plastic rod. How would you show the plastic rod gains charge? Anything to show attraction, literally any sort of thing. You could bring it near anything, and if it shows attraction. So a common one is, as you saw in the video, if you've got a stream of water and you bring a charged rod nearby, then the water deflects around. So I would bring a stream of water and see deflection. So any sort of thing like that. Explain how the plastic rod gains charge when it's rubbed. So again, we have friction moves electrons between the cloth and rod. Excellent. There are 2 types of charge. Excellent. Positive, negative. Describe how you could demonstrate this using different insulating rods and a cloth. Okay. So one of the things that does happen is if you rub different cloths, some become positively charged, some become negatively charged. And you can't show that by just bringing them near water because you can't really see that. So what we would do is we would have some kind of suspension system. So you saw one thing, you can suspend something. So we can suspend a rod and we can, charge it by rubbing. And then what we can do is we can bring an identical rod nearby, which let's say they both gained positive charge. by rubbing them. When you bring this rod, and we bring it here, well, this is going to deflect away. So we would see deflection because they're both positive, they're both away. If we have rod B, and rod B became negatively charged by rubbing, then we brought it across, well, this should be attracted towards it. So that's what we're looking for, attraction and repulsion. So we'd have some kind of suspend a rod, and charge it by rubbing, and then bring an identical rod near and observe repulsion, bring a different one and observe attraction. So that's what we would do. Okay, right. Number 3. This question is about electric charge. Well, that's not a surprise. When a balloon is rubbed with a cloth, the balloons become negatively charged. Tick the 2 correct steps below. So the balloons become negatively charged. So we've got negatively charged particles moved from the cloth off the balloon. Balloons become negatively charged, so I think that's correct. Positively charged particles are rubbed off the balloon. No, that's not correct because they don't move. Negatively charged particles on the balloon are protons. No, that's not correct. The cloth will become positively charged. Yeah, so those two are correct. When petrol passes through a delivery pipe, electrostatic charge can build up as shown in the diagram. Give a reason why build-up of charge can be dangerous. Well, it can cause a spark. State how the build-up can be removed, prevented. We can earth the delivery pipe. That's kind of what we need to do. C, the diagram shows coffee granules are passing through a funnel into a container. As the granules pass through the funnel, they gain electrostatic charge and they spread out as they fall. Explain, in terms of charge, why the granules are. Well, it's the same thing that's happening to all of them. They will all gain the same charge. And the second point is that like charges repel. And there we go. And that's how we can deal with that sort of a problem. Excellent news.